Hello there, welcome back. Today we're going to be taking a look at what we call volumes by revolution. This is when we take a function and we revolve it about a specific axis. For example, let's take a look at this little Amazon smile right here, and we want to revolve this about, let's say we want to revolve this about the x-axis. Now I'm going to put this little curly Q on the x-axis. That's it, I'm going to revolve it. So you kind of imagine we're going to revolve it every point here about the x-axis. You can almost imagine like a cylinder being formed here. And it would look kind of like something like this. On the other side, it would have this part to it, right here. And you would get these little, you would get this big old cylinder right here. So what we did here was we just got a volume by revolution. Now today we want to talk about how do we figure out the volume of this solid that is formed. Now to do this, we're going to go back to what we've been using, that rectangle of mathematics. Now since I'm revolving to the x-axis, what I'm going to do is I am going to now draw a line from the function, the original function, all the way down to the axis of revolution. So for our rectangle, we always measure to the axis of revolution. That's going to become important for us later on. Axis of revolution. Now, when I revolve this around the axis of revolution, kind of imagine. So like imagine you're looking straight down the x-axis. I'm going to revolve. If this is my axis, if this is my rectangle of mathematics, if I revolve it, we're going to get a disk. It's going to look like kind of a circle, but it's going to have thickness, so it's going to be a disk. It's almost basically like a penny. So if I revolve it, there it would be. I would get like a disk. So, and that's what we're going to look at today. We would get this disk. Our rectangle, in other words, when we did area and volume by cross-section, becomes a disk in this case. So our rectangle becomes a disk. And that's what we're going to draw. We're going to draw our disk. Whoops, everyone does that. So we're going to draw a disk. Now, it does have thickness. Most people skip this part because they can't draw it. But that's what it's going to kind of look like, a very skinny disk. Now remember, this is my skinny part down here, so since it's cutting with the x-axis, that's my thickness. That's just going to be dx. We talked about it yesterday. That's our secret thing, right? That skinny part is always d, whatever we're in terms with. And since we're in terms of x, it's just going to be dx. This is what is called the disk method. Now, in the center of our disk is our axis of revolution. There's our x-axis. So we just have to go to a little bit of geometry. Well, how do we find the volume of this disk? Well, we know from geometry to get the volume of the disk, it's just the area of the base times the height. And since the face is going to be a circle this time, like a penny, like this penny here, since the area is going to be a circle, the volume is going to be pi r squared times the height. And again, the height here, again, just like yesterday, that's always going to be our dx or d whatever, okay? That's never going to change. So the question next is, well, how do we get our radius? Well, the radius, that's our rectangle. The rectangle becomes a disk. But that height, remember this is my rectangle of mathematics. That's my radius. That rectangle that we used earlier becomes the radius of our disk. So my radius is just my rectangle. And again, it's just going to be top, which in this case is going to be f of x minus the bottom. Again, I'm in terms of x, top minus bottom, which is just going to be 0. So my radius is just the function itself. So to get my volume of my one disk now, it's going to be pi times my radius, which is just f of x squared times the height dx. This is what's called a disk method. So how do we get the volume? Well, there's a quick little formula for us. The volume is going to be equal to pi. Now, that's one disk, but remember, we're going to be making it rain pennies, okay? We're going to make it rain. We have infinite number. So we're going to go from A to B. We're going to make that disk go from right to left. And we're going to have an infinite number of these disks, which, to sum them all up, we're going to use our integral, and that's just going to be our function f of x squared dx. And we evaluate that from A to B, whatever the domain is. And that's how we find our volume. Now, we're not going to do all of today's notes today. We're only going to do a few examples, but you'll get and we're going to finish them up on another video. So let's see here. We're asked to find the volume of the solids by revolving the following region. Y equals 9 minus x squared, x equals 0, and x equals 3, and y equals 0. And we're going to revolve these about the x-axis. Now notice, first things first, we have to know what this looks like. So we're going to graph it. This is a parabola. We're not looking for anything accurate. Now notice my domain goes from x equals 0 to x equals 3. And of course, y equals 0, that's of course just the x-axis. So that's telling us we're going to measure to the x-axis. You might recall for area between curves, that's going to change tomorrow. So we're going to graph our parabola 9 minus x squared. We should know what that looks like. And I'm only interested in the first quadrant. That's kind of what this tells me right here. Quadrant 1. So I'm going to go down like this. And I'm going to shade it, the region I want, bounded by this parabola and these 4 lines, right? The parabola. And that's going to be the inside. And I can sing my shady song. Slim shady, Slim shady. There we go. Now, they're telling me we're going to revolve this about the x-axis. This is our axis of revolution. And this is nice because we are going to be in terms of x. So this is going to be our disk method. So what we're going to do is we're going to get the radius. Well, to get the radius, I'm going to measure. So let's define what a radius is. You want to write this down. The radius is the distance from the function to the axis of revolution. Okay, so that's how we determine what a radius is. So what's this going to be? Well, if I go from the top, I'm going to measure straight down to the axis of revolution. It gets a lot harder when we go between two curves. So we want to make sure we understand this today for today's lesson. And there's our radius. We are going to rotate around the x-axis. So when I revolve my radius, we are going to get a solid disk. And that's going to draw. So we're going to draw our disk out. Isn't that be pretty? It's just for you. Go to the center. There's my x-axis. That skinny little part down here, there's our dx. And this is my radius. Well, how do we get our radius? Again, it's going to be top minus bottom. Well, the top is just my parabola, 9 minus x squared. The bottom is going to be our axis of revolution, which is a 0, and we get 9 minus x squared. So my volume, let's see here. To get my volume, it's just going to be, remember, pi r squared h. Remember, our secret h is always dx because we're going about the x-axis. So my volume will be pi. My radius, which is this 9 minus x squared dx. And we're going to evaluate that, be careful, in terms of x from 0 to 3. And that will find our volume. So let's go ahead and solve this one out by hand. We would get pi. Let's see here. Now we can't integrate just yet. 0 to 3. 9x minus, be careful, this becomes, what's that? If I integrate that, that becomes minus 18x squared plus x to the 4th dx. No calculator on this one. And I can evaluate this one. That's going to give me 9x squared over 2 minus 6x cubed plus x to the 5th over 5 from 0 to 3. And we're just going to multiply this answer here by pi. And then, of course, you would get, oh man, let's do some math here. This becomes pi, and that becomes 81 over 2. Plug into 3, 18 times 6, I don't know what that is, minus 18 times 6, plus, don't know what 3 to the 5th is either, so I'm just going to leave that, 3 to the 5th over 5, and most part AP will be okay with that. So let's go ahead and see what this would actually be in this case right here. We can type this in our calculator as well. Again, if you're using the CX, just the same. So I'm going to type this in, menu for 3. Again, if you're using the CX, it's going to be menu for 2. And I would go from 0 to 3. Type in my original integral, or I can type in my factored form, it doesn't matter. I'll type in the original, 9 minus x squared dx, much faster than doing it by hand, and I can get this as a decimal, and that is equal to, and I got to multiply that by pi, don't forget the times pi, most of you will miss it because you forget the pi, 407.15 for the answer. Don't forget to multiply by pi. Don't forget the dirt, in other words. Don't forget pi in your answer. Alright, very easy to do. Alright, go to the next video. We're going to take a look at about revolving this about the y-axis. I'll see you then.